Good afternoon. This is Pietro Perlo, the chairman of I-FEVS Manufacturing, and together with Dr. Karasicov, the head of the payload branch at NanoMotion, we will present the development we have on a low-cost sensing platform for autonomous vehicles. We will follow as much as we can the suggestions of the organizers, describing first our company, and the goals we have in terms of development towards autonomous vehicles. We will emphasize, of course, the development we have and the need to collaborate with other Israeli companies. Now, I-FEVS was started in 2011. I was a former director at Centro Ricerche Fiat. We are focused on manufacturing safe, efficient, and let me emphasize, affordable electric vehicles. We start from 138 granted patents. We collaborate with a large number of R&D organizations in the manufacturing world. Our business model is very simple. We collaborate with national entities to produce electric vehicles. We are currently producing fleets in Italy, and we are addressing large-scale manufacturing in other countries. In Israel, in particular, the idea is having a manufacturing hub of innovative electric vehicles. In our factory, we develop passenger vehicles, vans, and bikes, and in the future also non-road vehicles. Now, the starting point is our van, which we already have and we are already producing at fleet level. The idea is to move from conventional vehicles to low-cost autonomous L4 level by 2024, and for this we are already supported by a grant of the European Commission. Now, for this to be possible, of course, we have possibilities of we need to satisfy many requests in terms of functionalities, and to satisfy all these requests, one single technology, of course, is not sufficient. We need a combination of lidars, radars, and cameras to get, let's say, the performance needed for fully autonomous. Now, all of this, of course, is scaring in terms of complexity, because we have far-field visions, near-field visions, and we have side vision. We need park assistance and so many functionalities, which indeed require hundreds of people usually to develop the needed sensing platforms. Now, lidars and radars are relative sensing unit, and of course this needs to be combined with advanced navigation solutions, including GPS. Clearly, this is a very high level of complexity. Now, let me provoke a little bit this conference, saying that lidars and radars follow the postulation of the extra emission theory, which we essentially rays emitted from the eyes, a theory that was endorsed since the 5th century before Christ, and that continued for some other 2,000 years. Now, with lidars and radars, usually the sensing suite are composed of 20 up to 30 sensors, and this means complexity, high computation, and cost. Now, in our case, we are proposing an alternative, which is a more modern way of thinking, if you allow me this provocation, which is addressing a reduced overall complexity, reduced computational effort, increased performance, and first of all, reduced cost and the simplicity of installation. So what is this alternative? The alternative we are proposing is the Velox alternatives. That is the gimbals developed by NanoMotions. What is the alternative that we are proposing? It is the Velox alternative. That's the NanoMotion gimbals using an infrared and invisible sensing, scanning the horizontal and vertical axis. Looking at the performance of these gimbals, you see that we are starting from conventional cameras in the visible, and we are also using today cameras that are quite expensive in the infrared, but we have already understood what we can apply and already produced in Israel, by the way, replacing the current US sensors that are introduced in the gimbal. Let me emphasize that the gimbal are quite robust. They are already used in the military world, and they, of course, satisfy the standards, but still not enough for what we are addressing in the automotive in terms of sealing and low cost development. Now, the peculiarity of this gimbal is that, of course, they scan the environment horizontally and also vertically, but they also do another thing. They can work together in couple, doing a triangulation. This has an implication in terms of simplicity of elaboration, because you start from an image and at the same time you also have a simplified interpretation of distance and size of object you are encountering. Now, looking at the overall performance of the proposed sensing platform, you can see that there is a human recognition at 900 meters, human classification at 400 meters. During this parallax I was talking about before, we can do some distance estimation, but also very important is that we have dual thermal and day sensing, which means that the visibility also in various climate conditions is absolutely acceptable. Another important aspect that performing optical flow analysis, we can also think that we can work in a GPS-denied environment. Now, as I was already saying, the simplification in terms of computation is indeed very promising, in the sense that we start from images and also from triangulations. Now, another important aspect for the automotive is that you should not only think in terms of the final L4 autonomy, but you can also go step by step, because simplified versions of these gimbals can be used for, let's say, a step-by-step approach in other systems. Now, how do we introduce the gimbals in our vehicles? The preliminary installations we were thinking of were gimbals outside the cabin, but we also have now a solution for gimbals inside the cabin, simplifying very much the development of the gimbals in terms of sealing properties. Very interesting is that the invisibility around the vehicle is very limited, which means that we can reduce very much the number of other sensors usually needed when applying lidars and radars. So altogether, the motivations we have to adopt this solution is the overall reduced complexity, reduced computational effort, high performance, lower cost, and simplicity of installation. We are essentially proposing what the animal world is doing, using eyes, combination of eyes, and eyes in movement together with the head. Essentially, we are propose a very sophisticated solution, which is a synthesis of simplicity, I would say. As Leonardo da Vinci was saying, simplicity is the last sophistication. Once we have the autonomous, once we have installed the gimbals on the car, we need the car to be autonomous, which means that we need unsupervised learning techniques. This can be done using standard digital processors. In fact, there are already very advanced digital processing units available in the market for this. But there is also another opportunity, which is using a novel embeddable analog MRAM-based accelerator, which, according to our estimation, is 10,000 times faster than what the market is offering now. For this specific development, we are collaborating with the Moscow Institute of Physics and Technologies and other Israeli institutions. Now, what is the market potential? For sure, LiDARs and radars and other combination of multi-cameras will reach the market, are already in the market, and the expectation is that by 2025 platform use and let's say a plug and use platform will be available by 2025 at $4,000, $5,000 or even less, and this platform will be widespread by 2030. There is large opportunities in road vehicles and also air vehicles, of course, with various form of implementations. Here, the market is indeed expecting huge developments within this decade already. And of course, there's another big potential in wheeled and legged indoor and outdoor robots, where the most optimistic forecast probably will underestimate the reality. In terms of what it is needed in terms of funding, the sensing suite is already available somehow, but some further miniaturization and adaptation to the automotive world is needed. We also need funding to finalize the development of the MRAM-based ASIC. We also are asking some funding to experiment a fleet of autonomous Ivan in Israel, but we are optimistic people, and we think that through the microfactory producing 50 vehicles a day from 2022, we can also support the development of the autonomous vehicle. Of course, the complementarity is foreseen with several Israeli institutions for that to be possible. Now, as a final summary, I would say we are proposing autonomous vehicles adopting a novel low-cost sensing unit based on gimbals. We are also proposing embeddable MRAM-based AI processors, which are 10,000 times faster than available unit. Very important, we are proposing a radical novel approach to manufacturing high performance and affordable urban electric vehicles. The idea is to start in Israel producing 50 vehicles a day from 2022. Aiming at becoming the producer of reference in the Mediterranean area. High strategic value for Israel because of the proposed high tech, because the impact on CO2 reduction, and also not secondary aspect, the impact on employment and the evolution of the local automotive supply chain. Thank you for your attention. You can contact me at the number he reported, but you can also contact Dr. Karasicov, who consulted me for the foundation of I-FEVS Manufacturing Israel.